All right, hello and welcome to this video. This is our second video on proportional relationships. Okay, today we're going to add to it the equation of all proportional relationships, and then we're going to use that equation. We're going to create tables, and we're going to look at a proportional and a non-proportional situation. Okay, so let's say you're driving 30 miles an hour. You drive this you're driving exactly 30 miles an hour down the road. So at 1 hour, you're at exactly 30 miles. At 2 hours, you've done 30 more miles. That'd be 60 miles. 90, 120, 150, 180, 210, 240, 270, and so on. That pattern. How do we go from the first column to the second column? Well, we multiply by the unit rate. So we take X times the unit rate, and it gives us Y. In this case, let's use some numbers. So I'm going to use this row right here. If I take 90, that equals 3 times 30, my unit rate. Okay, and that works. 3 times 30 is 90. So we have an equation, and it is always true for a proportional relationship. Y equals K times X. So down here, let's read this out loud. The unit rate K times the input X equals the output Y. The equation to all proportional relationship is Y times KX, where K is the unit rate. So then we can go ahead and use this equation in other avenues. Okay, so Jimmy can run, let's do number 3, 30 meters in 40 seconds. So if I want a unit rate, okay, it would be 300 meters divided by 40 seconds. So my unit rate, let me open up my calculator. Let me get rid of some apps here, too much open. 300 divided by 40 would be 7.5. So Jimmy can run 7.5 meters per second. So now that is our unit rate. So that's my K. So now I can write an equation. Y equals 7.5x. And you might be saying, why do I need this? Well, this is super helpful when answering the following question. Jimmy runs for 127 seconds. How many meters did he run? I don't know. That doesn't play nicely with 40 seconds. I can't just multiply it by 2 or multiply it by 3. But seconds is X. Because if we have an XY chart here, we would have seconds there and meters here. Whenever we have time is always X. So seconds will go in for X. So we can say Y equals 7.5 times 127. And this will give us, let me go to my calculator, 7.5 times 127 gives me 952.5 meters. Okay, that's a very specific answer, but that's what we do. If you want to know why, you can take and plug in a number for X. So we took out X and we made it 127. Okay, flip over to the back. We're going to talk about 2 examples here. Okay, so Mark is running and his fitness tracker is telling him he's burning on average 110 calories per minute. So do you hear that? Whenever I write something like that in a problem, that's automatically the unit rate. So we don't have to calculate it. We're just going to use the unit rate. Now, when we go our equation, so the answer is yes, it's proportional. So that's the answer to the first question, proportional. The next equation, the thing is the equation, y equals 110x. So x and y. So what we do to find out y, calories, I'm going to take this 2 and I'm going to plug it in for x. So I'm going to take 110 times 2, which is 220. 3 times 110 is 330. 4 times 110 is 440. Now, these last two, I'm going to have to use my calculator. I don't know exactly. Let's do the bottom example first. when moving to the right, we multiply. So we're going to take 14.5 times 110. I give this example because it's not a pretty number. 1595. Now, when we're coming backwards, we divide by 110. So we need to come back. So 825 divided by 110. Gives me 7.5 minutes. Okay, now we've been given a situation. We've created a table. We've created an equation. Now we need to go and make a graph. How do we make a graph? Well, we've got all these x, y's, so let's just go do it. So 1, 110, 2, 210, 3, 330. I clearly made this scale super easy on you guys. And so on. It always goes through 0, 0. Because if you've been working out for 0 minutes, you've burned 0 calories, obviously. If you find a workout that burns calories without having to work out, let me know. Okay, draw a straight line. It is a straight line through the origin. So there we go. We're done with that example. All right, now this next one. This one's a little weird. A fruit delivery company charges $10 setup fee plus $5 for every box. Oop, here's a little bit of Mr. Saffel's editing issues. So this should be boxes of fruit, and this should be dollars. Now, do you see this setup fee? This setup fee is different, okay? This setup fee, we pay it before we've ordered a single box. So we pay $10 for the first box, or for before we've ordered any boxes, sorry. Then if we only order one box, we pay the $10 setup fee plus $5 for the box. Then we pay another $5 for the second box, and so on. Notice how it's a consistent change, but the unit rate is not going to be there. So let's do this, okay? 15 divided by 1 is 15. 20 divided by 2 is 10. Do you notice how it's changing? It's not the same. 25 divided by 3 is 8.3 repeating. 30 divided by 4 is 7.5. 35 divided by 5 is 7. What's happening is the more boxes of fruit I buy, the less per box my cost is. So the answer to proportional is no, not proportional. Let's look at this on a graph. 0, 10, 115, 220, 325, 430. That's enough points. We draw a line. Let's look at this. Is it a straight line? Yes, it's linear. Is it through the origin? Remember, this is the origin right here. Does it hit the origin? No. So that's another reason why we know it's not proportional, because it misses the origin. All right, well done following along and listening and taking notes.